Go live button. All right. Checking mic. Mic looks good. Maybe pull it towards me just a bit so I can't see anything. Um, okay, so I forgot to set up a reference image, so I'm going to do that quickly off screen. Da, da, da. Monolith challenge. Oh, I can probably just. Can I do it just from the browser? That'd be rad. Hey, check it out. Cool. Okay. That looks terrible though. One sec. Oh, goodness. Properties. Here we go. No. Transform. Here we go. Reset transform. Oh, whoops. I goofed the URL. There we go. Okay. Transform. Edit transform. Crop left. Crop things down a little bit. Oh, I should start music. Steps tracing Kara, like usual, just because it's good. Crop top. Looks good to me. I'll drag that up in the corner there. Make that big enough to see. Okay. I should probably get that up in a window for myself so that I can see it. Okay, so we've got roughly what looks like a motorcycle or some sort of two-wheeled vehicle triple clamp here. I'll pull up some examples just to show you what I mean. It is specifically a structure that sits at the top of your suspension and holds your handlebars, it holds the top of your front forks, it holds all the little bits and pieces and odds and ends that serve as most of the front of the suspension of a motorcycle. I'm pretty sure that's what this structure is, based on like sort of the two tubes that it's clamping onto. There's really not anything else it can be. So, I mean, yeah, let's get to it. So, let's see, we've got a... Let's just start with the top profile first. We have an overall height, 60 millimeters. I think I want to put my origin probably at the base of that. No, let's put the origin at the top because it's the top surface that we're working with. Oops. Lines do that sometimes. Oh, I must have moved. I've changed my defaults a little bit at work recently, so now none of my shortcuts are in the same spot. But we're just gonna quickly trace out this outer profile. I was kind of hoping it'll give me a 180, but I guess it doesn't want to. As an example, when you trace off a line vertically and drag off it, Solidworks will give you a point that matches 180, so you can quickly give things that are in the right spot, even if they don't have the relations yet. Let's add this bottom curve. Oops. Select both, Alt-A, make them tangent. They're all goofy, that's fine. And while we don't have relations here yet, that makes it a lot easier to sort of drag things around and make them really work. So let's get some controls on that. Make that tangent and is 35 millimeters in radius. And this guy over here, there isn't actually a dimension on the drawing for this one, which you can suss it out based on how you've got that 22 degrees on the upper right end. Like, this 22 degrees right here is like the only... Oh, hang on. I just realized I have a perfect tool for indicating... Oh, where is it? Where's the thing? It's in here somewhere. Power Toys, if you don't know about it, great tool for like just doing weird stuff. It's a great like pack of little. Where is my mouse? Where's my mouse controls? There's a way to get it to on double click of control to. Am I on like an old version or something? Yeah, wow, I'm on version 35. Okay, that's old enough. I'm not going to do that right now, but... No, actually I should, because it's a really good tool. Power Toys, release page, Power Toys. Dunk. Let's get that out of the way. Downloads, installers, Power Toys. Come on. Run. Thank you. I agree. Yes. Install. Yes. In the meantime, we'll keep modeling. So I know this is roughly 22 degrees. I know that the OD of this part, get that out of the way, is also 35. Interesting. I wonder why it's the same on both of them. 35. And we know we can bring that up here. And this radius up here is 200. Now with this, pick that, pick that, pick that. Right click, drag, symmetrical, part's done. And I just set this to 200 per the drawing. There we go, there's our profile. I'm not going to fill anything else out yet. That's a lie, I'm going to do the big holes, the big bores, because those are pretty... And I could have added that in the symmetrical as well, but I didn't. Whoops. Have both of those. Alt Q, features, extruded boss. I'm going to extrude down, so that leaves me with an origin that's at the top center face. Per the drawing of 60 mils thickness, put that down. Cool, there's our basic shape. Power Toys is still updating. Let's do an extruded cut from the front now. Because that's sort of the next major thing we need to start cutting away the profile, is getting rid of this mass here. Which leaves me in a bit of a conundrum, because I'm not actually sure how all of this is defined. Like, this isn't super clear. 30, 30, 20, 19, okay. 28 millimeters, okay. I think this edge starts at the 66 millimeter point. But if it doesn't, I've got no idea. It looks like it might also be 32 millimeters thickness, and we'll just double check that at some point. But ooh, I kind of want to try the new open edge cuts, because I don't do that very often. We'll do this again with the symmetrical tool. Whoops, a whole bunch of things. Okay, 45 degrees, and it's not indicated on the top, which means it's probably parallel on both. 45. Is Power Toys done yet? Yes, it is done. Is it running the new version now? It is! Check it out. Mouse utilities. Find my mouse. Yeah, there we go. Now get a little mouse highlight. Awesome. Okay, so now I can indicate stuff clearly. This 22 here, and I wish they wouldn't add a white overlay, because it clearly does put a little bit of white over it, but eh. Oh, maybe I can customize that. I totally bet I can customize that. Mouse utilities, find my mouse appearance and behavior, spotlight color, spotlight radius. Let's do like 200 because I need a little bigger for big screen. Overlay opacity. Ah, but you can't make it. Ah, hue saturation value. You can't make it transparent. No. That's annoying. Okay. Oh well. I'll just put this up here in the middle. Well, can I, like, Alt-Tab efficiently? We'll see if I can Alt-Tab efficiently. Okay, so 45. We know that we've got 66 millimeters length here. Looks like these are parallel, probably. Off the top surface, we are 32 millimeters. Off the bottom surface, that's a little sketchy. I'm going to add a line there. It's important to control your relations as well. Like, this is coincident with that line, which is a little iffy, but, oh, better yet, I can tell it to be coincident with that face, and that way it'll always be cutting off from the bottom rather than having to specifically refer to that line. This one is also difficult because I think it's coincident with like a non-existent, like an edge that doesn't really exist. And this one is coincident with this edge, which I don't want. I want it to be coincident with this. Okay, that's probably good enough for now. Add this 32 thickness here. And then we don't really have a good control for how thick this is. But if I set this to 32, I would... No, dang it. Oh, no, I forgot. It's because there's a fillet, too. I'd bet almost anything that this is also 32 millimeters thick. It's sort of the only one that makes sense. So we'll do an extruded cut through all in both directions because we're cutting from, if we look at where the sketch is, it's on the front plane, which is going to have to cut in both directions to get all the material off. So now we'll do some fillets to get our profile because those fillets are actually important to exist beforehand, I think. Well, maybe not. Let's do these guys next, these little cutouts. So we've got 48 millimeter depth from the center of that bore. And looks like it's right on center. And it's 1.5 millimeter radius, so 3 millimeters width. I probably would have dimensioned the width, I think, even with the radius. Yeah. Let's do no fillets yet. Oh, I didn't change this to be extruded cuts yet. I have a signal message to myself with all my new shortcuts, but I haven't changed them here yet. Let's do top plane. And I'm just going to do this with... ooh, I should reference the sketch instead, actually, since that's sort of the critical defining feature here. I can make this... not collinear, sorry, parallel. Make that 48 millimeters long. And just from a design intent perspective, I would always say that as like I'm defining a gap, I'm not defining the radius on the other end. The radius is almost even incidental, except for stress relief in there, but it's still under compression because of the way the structure is designed, so not really that big a deal. I'll do the same thing with mirroring. I'm pretty sure it'll let me mirror this easily. Yes. Technically there's a construction line as part of the slot, but the way Solidworks treats slot entities, it's one contiguous thing, and so you can still select one construction line and let you mirror, and it lets you mirror things. So we will do an extruded cut through all. And if I do this first, then it also gives me the opportunity to look at, let's see, this bore is what we care about next. Does it say, yeah, 60 millimeters up from the base, 33 over from the end. And that's got to be tapped. So we will do a hole wizard. And because this part is symmetrical across X, I'm going to use a 3D sketch, and I'm going to do 2 of these at once rather than, well, hang on, no. I will do it 1, and I'll do a stack up of 1. I'll do all of the features that I need, and then I'll do 1 mirror at the end, and then I don't have a whole bunch of separate mirror feature or internally mirrored features with their own like mirror silliness. So type, whoops, type is a threaded. What's the clearance? 8 millimeters. So quick check M8 socket cap screw dimensions. Images. Nope, hang on. M8, head diameter 13. Cool. So that is definitely designed for an M8. Which is kind of a big clamp bolt, actually, for these. They only take a couple of, like, on the order of 10 or 20 Newton meters for clamp bolts, or pinch bolts, I think as they're usually called. Anti-metric. Straight bottoming tapped hole. Not up to next, but merely blind. And I am not going to do this. Oh, hang on. No, wait a minute. I need to do this for the drawing. I can't just engineer this correctly. I'll get rid of this while I'm here, too. I'll mirror everything later. Ooh, I do need the fillets though, because otherwise I have to fillet that twice. So we'll do that before this first cut extrude, or rather right after it. So we've got 30, 30, 2019. Okay. At that sketch while we're up here. We'll do a multi-radius fillet, and that will let me, pretty sure that lets me like add all these fillet features in one go, which isn't the most necessary thing, but whoops, wasn't done adding fillets yet. Nope, not that. Let's see, 30, 30. No, this underneath one is 19. This top one is 20. Is that right? 19, 19, 20, 20, 30, 30, 30, 30. Cool. Okay. Fillets. Cool beans. Oop, I didn't do keep surface. And we can check his model as well to make sure that that is the case. Yeah, that's one contiguous surface, so it doesn't change there. It would show hidden lines in the drawing if it did. So we can go down to fillet options and say keep surface. There we go. Straight lines. Now our cut extrude cuts through just fine. And next up is the hole. We are dealing with counterbore to a depth of 22 millimeters past that, and that's 35, so overall depth is... Oh, I'm gonna have to do this with like a custom hole, or tell it to put a counterbore at the front. It's the easiest way. Because naturally I'd want to design this with Solidworks tools for saying, hey, make this a hole with threads in it so that the callouts come out right, but... Yeah. 22 from a 35 outer radius is going to be 57. Lozard. I almost want to do advanced hole just because that'd be easier, but no shortcuts. In condition, we're dealing with to where that cuts off. Not hex bolt, but socketed cap screw, M8, normal, show custom sizing. We want this to be, we want this to be, well, I have to do it to those dimensions, so. And that goes to 10 depth, which is a little more than usual. And he doesn't dimension that endpoint. I mean, we can assume it's a nominal 118 because he was probably using SolidWorks. Probably using SolidWorks. But depth is going to be 55. Positions. Just pop that guy here. Do I want to use that reference edge? I don't think I do. I think I want to show this sketch. Define that relative to Tell you what, let's convert that. Make a construction just so we have like a reference, and then we can reference the midpoint of it and say 33. And because we cannot reference surfaces in sketches, unfortunately, that'll just have to be 16 for an edge. Not the biggest fan of that, but it is what it is. So, but now we say OK, and now we're geometrically accurate. Cool. So next up is this cutout's going to be really weird when we section that through there. I think I want to do this. Let's do this slot next. Or, oh no, I can do. What is the deal with that hole? What is that hole's deal? Does it ever get a called out radius? It says they're 80 millimeters apart. And it looks like they might get a counterbore or something. Oh, they're not fully dimensioned. No, they don't have the diameter. They don't have, like... I don't think they have a call out. How long have I been going? 20 minutes? So I'm specifically worried about this little hole right here in the center. Like, those aren't, they're not defined. Which isn't great. But I said I was going to do it, so. Let's see, Extruded Cut up next, top plane. I'm going to try and reference this because that's, I mean, origin and that's what matters. I can even hide the solid body, really. So we've got vertical line here, perpendicular to that, and we come back down. This is parallel to that. It's 8 millimeters away. I think it's 8 millimeters away. Is that what the drawing says? Yeah. 8 millimeters, and then 13 to the center of that radius. 22 and 15. Okay. Which means we can just leave this vertical. But it means we need to have the... since this is defined from that edge, we need to have the radii built into the cut section. Oh well. We'll remove that and put it on the far side just to get things out of the way. So I think that was 13 and 15. Ooh, they're not parallel. 15, I think. Looks about right. Welcome to the stream. Chat if you like or don't. I'm gonna keep trying to narrate things though, so. So we've got 15, 22 degrees. That's fine. Having this one be perpendicular to the sky puts everything in the right spot. And then we want it to be 52 off center line. So I'll just do that by grabbing the origin. Better than grabbing the sketch wherever possible. You want to limit your external references if you can. So now we unhide it, say Extruded Cut. That's actually, I should show off this trick just because it's kind of interesting. If you hide a body when you're doing a cut, Solidworks will just assume that it's not there. So if I say up to next, like go all the way through, it'll say intended cut does not intersect the model. You can control what bodies you're applying cuts to just with visibility in the graphics view, which is handy. It's weird, but handy. I should save this too, actually. Reddit, Clamp 2022-02-26. That's one of the cuts. What else do we need to be mirrorable? Ah, we need this. How does that get clarified? Okay, 17 millimeter thickness. And 33 millimeters, so... And it's vertically aligned, which is a little strange. I probably would have aligned it to the... like... I would have, instead of having it be vertically aligned, I would have aligned it like this. So that, there we go. I would have aligned it this way so that you minimize the material you're removing and just save weight. Or just reduce stiffness on the exterior. On the other hand, this is probably still thicker than it needs to be, so. Let's do this with a plane. Whoops, nope, I started a 3D sketch that way. I'm using, like, the search, but sometimes it brings up 3D sketch plane, and then you're in a 3D sketch when you maybe don't want to be. So let's do these two, get myself a midplane, add a new sketch. Go up, and up, and up. Ooh, I should see if I can't avoid that referencing the model itself. Coincident, centric, 33. We'll make this guy, no matter what, collinear. Features, extruded cut. Whoops, why is that not letting me do... Oh, because it's... Well, let's just convert this face. Convert entities. I'll just trim away the rest. Sometimes it does have to just be referenced to the... Ooh, wait, no. I can convert the sketch instead. I can convert the whole sketch. And then I can say extruded cut, midplane, selected contours, and then I can pick just that one contour. This is a trick that I discovered recently that seems like it's really handy. Like, you just convert the whole sketch and you tell it only care about this contour surrounded by these entities. You don't get any weirdness when you change other entities and like it adds or removes things in the sketch. You're just always referencing that section. So let's, whoops, don't need another sketch there yet. Hide that, hide that. So now I think we're looking at all of the independent features we need on one side. So I'm going to go ahead and mirror those. Go doot, 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 doot. Looks good to me. Say okay. Sweet. Let's do some quick cleanup and naming. So, profile fillets. Top profile extrude. Front profile cuts. Clamp gap cut. Right, socketed cap screw, C-bore. Hole. We've got the clamp stress. We'll call this the clamp flexure relief. Because if I'm looking at this model right, when you clamp down on this bolt, you'll want to bend this whole bit inwards, which you've got a lot of material for that little bit of steel to move. Assuming this is made of aluminum. It can probably kind of do it, but it's still, it's not how I'd go about it if I was designing a clamping fixture. And this is the exterior clamp relief cut. And rear clamp features. This one is, whoops, we should name the plane too. This is the clamp midplane. Now, clamp features, which successfully grabs everything that's clamp related. I think there's probably some chamfering and things to do later on. Well, I guess maybe not. Maybe it's good as is. Okay, so now I need a really complicated hole that... Oh, those are counterbores from the underside. What? Oh, hang on, that's totally called out. I'm dumb. Goodness. Thank goodness, actually, because I was worried that those holes just like weren't described at all. 22 profile, 28 millimeters, so I guess it's just 28 millimeters in the bottom. I can't think of any other way to describe that, so that's what I have to go with. Yeah, that's what this weird edge is right here. That's the counterbore, and since we know we're at we know we're on center line with this bolt because that 8 millimeter diametric dimension is out, and we know that that's 60 millimeters up from the bottom. We know that we have to have cut through right there, so let's do that. That means one more feature to add to the clamp, which reinforces that it's probably a triple clamp because those bolts would have to go up through the bottom to grab the bottom of your handlebar clamps, or what are they called? Handlebar clamps. Yeah, handlebar clamps. Handlebar riser clamps. That's what they look like. Normally they bolt in from the top and you bolt through them, but there's some other styles too. At least on dirt bikes, it's a pretty standard 2-bolt pattern, I think, with M8s. Oh, Clay Brother, good song. Just for reference, we're still listening to Zeph's Chasing Kara, so... I wish he'd put out more music. It's just one guy somewhere in the UK putting this stuff out, and it's so good, and he only put out just a little bit of material, but... let's do it all day if I could. So, Hole Wizard from the bottom. We want to be on the underside of this plane. And we've got this kind of weird... Okay, so what is it? It's 10.5, 22, and I think... Oh man, it's hard to tell. I'll just have to like probably tweak it later, I guess. Let's go for an M10 for now. Make this say close, and what does it give me? 10.5. That's about right. 22, about right. Depth 28, 118, but we want to go up to next. And the surface is this one on the bottom. We'll just put it there, bring it over. I'm going to add a line here so that I can give it that, whoops. If I was doing this from a perpendicular view, it would be a lot easier. Make that 80. If you had a center line, you can do things diametrically, which is handy. Add that point, and that point, say 20 mils. I think that's what the drawing gives. Yeah, 20 mils off center, the big guy. And that looks about right, and gives us the right amount of sort of cut through. What's that look like in profile, actually? Let's... That seems about right, honestly. If I do it the other way around, and I say, make this 32 in depth, that looks deeper than it is in the drawing. So we'll stick with 28 here. Call this the M10 socket head cap screw, underside C-bore hole, and add that to the set of mirrored features. Do a quick save. Looking good so far. Okay, next up is... Oh man, I am not looking forward. Oh no, never mind. Did he... Is that filleted? What is the deal there? It looks kind of like there's an exterior chamfer on this. But I don't know. Like, there's a lot of specific chamfering that's not really called out. Unless those are radii in the exterior. They are radii in the exterior, and the way I can tell this... Hang on. So, we can see in this view that he showed tangent edges, but he didn't in the sort of profile view, probably because it would have looked too busy. Yeah, those have to be fillets. Oh man, that'd be such a pain in the machine. You could never have that on a production part. They would have to be, it would have to be chamfers, and you'd have to specify that handwork is okay or something. I mean, you could tell him to CNC it, but with the part designed this way, it's probably designed for something that wants to be like kind of cheap, so it's probably done from a casting first, if I had to guess. We'll have to save all that to the end. That's for later. Let's do this top hole now. So 43, 24, depth is 5, and then 11 on the back side. So I think advanced hole is actually the right tool for this for the first time in a long while. I don't really use it all that often because it just isn't something I really need to add element. Let's see, and add one more. So this is going to be a far side counterbore. And we've got, oh, we don't actually have a chamfer. But it looks like we've got a fillet. Ugh. 2x45? Is it chamfered on the inlet too? But it doesn't show up in the model. Ah! Oh no, that's chamfered on the bottom backside? Yeah, okay, I guess that's 2 chamfers. It's really hard to tell. That top surface is small. Okay, so under here, this is custom sizing, yeah. And symmetric, at least, so I can do this in same units. Near and far side faces this one and this one. So up here, we want asymmetric, asymmetric. I almost think this is going to be easier to do with a revolve. No, because the counterbore is going to get funky on the bottom side. Yeah, let's keep using the advanced hole feature. Let's see. Okay, so we got a far side, we got a near side and a far side. Top one is going to be asymmetric. Counterbore, I'm just going to custom size it. It's going to be awful. 43 and 5 mil depth. Oh, hang on. I can remove elements from this. Near side countersink. I'm not going to put a countersink here. And maybe I'll just make this a plain hole. Maybe that's easier. Because then I could just specify my custom sizing a little easier. So this is going to be, was it 23 and 5? Or 43 and 5? 43, 5, and 24. Four blinds up to next. Up to next, or not up to next element, but up to next element. There we go. And then this one is going to be custom sizing on the far side. Up to next element, but we actually want it to be blind. And it's 1150. Okay. 50, 11. Can I put an element on top of that? That's like a counterbore or far side countersink? Oh, that's jacked up. Oh, goodness. Okay, yeah, get rid of that element. Oh, locate it. There we go. Okay, so now if you go into section view, it's still jacked up. Awesome. Okay, maybe advanced hole isn't the right way to go about this, because it will always screw up stuff like this. I hate it. It's just so bad. Okay, revolved cut it is. Front plane, show the sketch. I guess I do kind of need the body to be shown, but I can at least develop the whole sketch down here first. So we've got, whoops, hang on, wrong side. Drag this out to 43. This one out to 50. Flat edge to flat edge. 5. Flat edge. 11. Quick check of that center bore. 24. And 24. Ooh, I actually don't need to show this sketch here because I could just grab this, make that coincident, and there's almost all that defined. And I'm realizing now that I can't just have that be that, because this has to go all the way down to the bottom face to make sure that I cut all the material away. Because this model is not great. I can pick this point and say I want you coincident with that surface. And then I can pick this edge and say be 11 millimeters deep. And I'm going to pick this one and say be coincident with that face, because it just is. Because I need to reach further, but I don't have an easy way to define that. It's the nature of dealing with models this way, is holes don't like being near fillets. And I would maybe put those fillets at the end, but it's just kind of messy when you have things that overlap with fillets that way. But we can call this revolved cut now, and it should work just fine. Pop right out. There is... hang on. I'd like to have it all be visible at least. Put that up in the right spot. And we can actually have the chamfer here too, or one of the chamfers. 2. I'm assuming that is a 2mm chamfer as marked. It's kind of hard to tell because there's a lot of other stuff that just doesn't really make sense here. And I could run into trouble in terms of this not actually being like a 45, like maybe it's one of these other styles of chamfer. I personally prefer to, when I'm modeling things for 3D printing, I like to use equal chamfers. But there's just no way to tell what's used. Well, it does say 2x45, but I don't know. What happens when I flip direction? Not much. I guess I just gotta assume that it's right. Okay, that's most of the features now, I think. That leaves us with just this quick slot counterboard cut in the top. I'm just gonna do that with a cut because it's easier. We'll do this with a center point straight slot. Grab that, grab that, grab that. It is 15, 32, and 7mm off. 15, 32. Its dimension is a radius, which is kind of weird. I'll add an extra line here so I can control where it is left, right. But I would prefer to do this, at least when dimensioning and modeling it, as a distance between a line and an arc like that, instead of defining it as a radius. Just makes more sense in my head. Extruded cut, up to next. Call this the steering hinge? What's the word for that? There's gotta be a word for that. Triple clamp pivot bearing seats. Backside bearing seat, 2-layer backside chamfer. Well, it's just backside chamfer. It doesn't have to specify 2mm, the feature name. And this is top weight saving slot cut. These are center features. Looks pretty close now. I think it's just the fillets on the outside. And these, and in here, which it looks like they might be on both sides, which is gross. And it would be very, very difficult to machine. So we'll do quick 2, disable tangent propagation, select tangency. I like to do this because it keeps Solidworks from, or if you change your geometry and like you care about where your fillets are, which I'm realizing now I don't actually, like that's always going to be tangent no matter what I do, so clear that, keep tangent prop on. Boink, boink, just faster. It could bite me if these like change how they're defined, but like if that face ceases to exist because the like if actually I can just show it too. Let me open up this feature, edit sketch. If I take this face, first of all it deletes that dimension, a little annoying, but if I replace that edge and say like for some reason it breaks and I need to repair it later on, that's 15mm now. Why is this no longer defined? Ah, because it's no longer tangent. Still not defined. Why is it not defined? Ah. Oh, because that's no longer perpendicular. Like changing and replacing an edge. When you know it breaks a whole bunch of things. But the fillet worked. Why did it? I would expect that to break normally. Weird. Maybe it got cleverer. But it's our fillets. I think that's every feature, pretty much. Yeah, I think that's every feature. So we're looking for 445, 582, 95. Mass props. 447, 334. So I still got some mass to lose somewhere. What if I... Let's see, I'm not missing any chamfers on the top, I don't think. What if I make these... What if I make these chamfers instead? Mass props. 445, 418? Still, now I'm on the low side. If I take these, or if I take this one down here and say, you're now an equal distance. 445, 418, still the same. Yeah, I don't know. Don't know where I went wrong. Ah, here we go. No, hang on, that's... Is that a chamfer? That's a chamfer on the entry and the exit of that slot. So... Let's move this... center features equal chamfer. Yeah, it says 2, front and back. Oh, and there's a chamfer on the front, too. But that's going to be losing me mass, not getting me back mass. Yeah, 2 millimeters, 2 millimeters, 2 millimeters, 2 millimeters. Evaluate mass props. 444, 689. Yeah, I think I'm going to chalk up any error in getting this mass right to 446. I'm going to chalk up error in getting this mass right to the fact that it is not fully defined in the drawing. Like, there are a lot of features in here that are simply, like, this, if we zoom way in on this, that to me, it just doesn't really look like, it's hard to tell if it's a chamfer or if it's a fillet. Like, this should have been exported as a PDF. This could have been, if a shop got this drawing, they'd probably send it back. They'd say, hey, we need a better drawing. Totally irrespective of the fact that there's no tolerances or anything on this. And things like R20, R30, 30, 19. This is called out as 20, but this isn't called out as 19, or that as 30 and 30. I'm assuming that this is supposed to be 32 millimeters thick, but it's never called out anywhere. The biggest problem that this drawing has is that there's just a lack of clarity. Like, you simply can't zoom in and tell. In a PDF or a DXF, you'd be able to, like, zoom way in, and because those are formats that are typically exported as vectors by Solidworks or Fusion 360 or whatever this was drawn with, you'd be able to tell that that's like, okay, that's a chamfer, or the chamfer? That's a chamfer, or a fillet. They might be fillets. It's a song, They Might Be Giants. I think that's a band. 52, 80, 20. Let's see, 22, 35. Actually make that 57 deep. Center distance. Let's go center to center. No, it's 55. Hey, that's wrong. Got to do it from the original one. That's 57. Evaluate mass props. 444, 497. Those kind of boards under there aren't chamfered or filleted, and it's not clear if they're chamfered or filleted up here. But that would still lose me mass. And right now I'm trying to gain mass back because I'm still like a whole milliliter under. Ooh. 66, 66, 32, 32, 32, 45, 20, 19, 19, 20, 30, 30, 30, 30, 48. That was 48, wasn't it? Yep, 48. 1.5, which makes that 3 millimeter gap. Oops. 3 millimeter gap. 14, 10, 57, 8, 16, 33, 15, 13, 8 off the side. Is it 8 off the side? Yeah, 8 off the side. And a whole bunch of unclear fillets. exterior major chamfer A. Yeah. I was really hoping I was going to get it right so I could produce a drawing that would be not only better and more useful, but also accurate to the original volume. But the original drawing is not specific enough to get the actual volume, so it's sort of a moot point. What's this here? Is that supposed to be in the center of that face? Yeah, that is. Okay. And it extends either side. Still makes sense. Yeah, well, yeah, I don't really know what to say. I can't. Well, we're almost at the end of my playlist anyway, so yeah, I don't know what else to say or how else to get to the final volume, but this part ain't it, Chief. Not to mention, if you actually try to clamp down on this. Well, actually, let's see if I can just load in simulation and see what a fixed clamp would do. Loading in sims. You study. Static. Yes, please. So, fixtures, fixed geometry up here. External loads. Connections, that's what I want. I want a bolt. And I want a standard or counterbar screw from here down into here. Alloy steel seems fine. Torque. Why is it giving it to me in pounds, force, inches? Newton meters. Well, this only needs to be like 20 Newton meters, probably. Add another bolt. Just add that to the library? What? Huh. I guess I should do that for like connectors and things. And just have like some standard ones that I can use. That'd be really handy, actually. Ugh. Not in pounds, force, inches. Torque should be 20 Newton meters. What? I did select concentric entities. Those are concentric. Oh. It picked an extra face. Rather than clearing the old one. Mesh. Just do mesh and run. Let's see what happens. I'm curious what Solidworks will just give... Oh, material's not defined. Fair. Material 6061. Yep, 6061. Run the study. It's not defined for bolt connectors. Sure. Just let it run, see what it does. Okay, so it says over yield strength, probably under the contact patches, but the deformation's way too big, so let's edit this definition. Scale the deformation down a little. True scale. User defined like 20x scale is probably, or 10 even, is probably good enough. ISO clipping. Zoom that out a little bit. Mesh seems a little bit chunky. Looks like it's just right in there that it got messy. Let's do... Can I just tell it to show mesh? Oh, wow. Okay, that's crunchy. One sec. That ran way too fast. Well, my music ran out, so I'm only going to do this for a bit longer. But I will, at the very least, tell it to do a better mesh. Blended curvature based. Reduce. Increase. Slow the grow rate. And this will give me a much finer mesh, which is fine. I've got plenty of RAM for something a little bit finer. So now run. Mesh and run. Well, I guess I didn't need to tell it to mesh and run. I could just hit run study. I'm not good at SolidWorks Sim yet. I'm a lot more used to ANSYS. Yes. Convergence Plots. Meow. I'll shoot right down. Oh, you know what? That isn't actually all that surprising. The highest stress is right there where it doesn't have a lot of material behind it. That counterbore might be too big, or it might need to be moved inboard a little. Or even that slot could be reduced. Let's do a quick check of displacement. No deformed result, please. Only 3 thou inward? That's probably about right. If we go in here with a probe and say what's there, yeah, moving about 3 thou. That would probably be enough to properly clamp a triple clamp. I wonder if I could tell it to show me. I much prefer SolidWorks, like show elements view. Okay, well, I'm not going to get to a drawing. I'll take that out of the description of the video. But for those of you that came and watched, thank you. To whoever's watching this later down the line, thank you as well. Always happy to have you coming and watching what I do. Yeah, I think that's pretty much everything. Have a nice evening, morning, midday, afternoon, all the rest. Boink.